Welcome friends, I am Tanmoy. I welcome you all in the channel Chemistry the Mystery of Molecules. Today I shall explain about another main reaction, that is Dieckmann ester condensation. Actually Dieckmann condensation reaction. This reaction is an extension of Intramolecular Claisen Ester condensation. So previously I have uploaded video about Claisen ester condensation. I suggest you please go through that video first, because the whole concept of Claisen ester will be utilized here, but I am not going to explain the Claisen ester again. So today mainly we will discuss about the mechanism, how intramolecular ester formation happens, and I will mainly give many examples which will be helpful, I believe, for exam purposes, some difficult examples. Okay, and this whole lecture series, this story I have taken from book written by Dr. Chandan Saha. So he is a retired faculty of Calcutta School of Tropical Medicine. So he published 5 books. So one of the books contains this Dieckmann condensation. I have taken it from there. So let's discuss. Here you can see that previously we know in Claisen condensation reaction was this ester plus this ester undergoes self condensation to produce a beta hydroxy ester. Okay, so sorry, this is ET. So this is Claisen ester condensation. Okay, so sorry, beta keto ester, not hydroxy, beta keto ester. This is the Claisen ester condensation. For that, alpha hydrogen is essential, and in order to complete the equilibrium, this last alpha hydrogen one is necessary, because in last step it is abstracted and make a negative charge, and that is the reason for shifting the dry equilibrium to the right side, because we know the Claisen condensation is a reversible reaction. Okay, so here that is utilized. You can see this is a 1,6-dioic acid, means hexane 1,6-dioic acid, hexanoic acid. It is obtained from cyclohexanone by the oxidation of V2O5 nitric acid, etc. Okay, so what happens? These undergo Claisen ester condensation. How? So if we write it properly, this is actually OET, and if this sodium ethoxide ethanol first abstracted this base to produce the carbanion here, which is resonance stabilized with this carboxylate group. So second step, this undergo reaction. Okay, so previously it was a 1,6, 1, 2, 3, 4, 5, 6 carbon unit. Right now this one is outside, so it's like a 5-member ring. So first initially this attack will happen, then it will come and it will push that OET goes outside. And what will be the product? This will be the product. This carbonyl group is actually a 6, 6, 5, 4, 3, 2, 1. So this is the reaction. Now you can see that driving force is the abstraction of this proton, because it's an active methylene group. Okay, so in first step, under this condition it will produce the anion here, and which undergo protonation by the treatment of dilute acid. Okay, this is fine. Second step, this ester group is hydrolyzed in presence of carboxylic acid, in presence of alkali. So what does it produces? It produces 1,3-diketo acid. Okay, so this is and this we can write this in a little different way, 1,3-diketo acid. And what happens if this acid is given heat, then under the thermal condition it undergo decomposition. How? If we write that this and this. So in this way reaction will go through a 6-member cyclic transition state and produces this 5-member thing after the elimination of carbon dioxide. So this is the overall. So you can see it's a strategy for the preparation of a 5-member ring. Okay, first of all you can see 1,3-dicarbonyl compound with a 5-member ring, and this decarboxylation may result in 5-member ring. So actually what we are producing, we are converting this cyclohexanone to ultimately cyclopentanone using this strategy. Okay, so this is the strategy. So let's discuss some other examples. Okay, let's continue the discussion. let's discuss this problem about this Dieckmann condensation reaction. 4 problems we'll discuss. Okay, let's discuss about the first problem. If you can see, the condition is sodium hydride dry ethanol, a dry ethyl ether, 1 drop of ethanol. Actually, what it produces under the reaction condition, it produces NaOET. Okay, I have explained the story of this reagent in previous Claisen condensation. Please go through that. Now the question, it will abstract alpha hydrogen. Question is, there are 3 types of alpha hydrogen: 1, 2, and 3. I have explained that in order to Claisen condensation actually a reversible reaction. In order to make the step irreversible, it is essential that the carbon should have 2. The nucleophilic carbon which is attacking should have 2 hydrogen. Actually, first 1 alpha hydrogen needed for the first step to generate carbon ion, and second step that carbon ion will react to prepare 1,3 dicarbonyl compound, and after that 1,3 dicarbonyl compound, the second proton abstraction will drive the equilibrium in the forward side. So consequently, if we see from 1, 2 and 3, only this has 2 proton. Okay, so this position will generate nucleophile first. Second, another thing, here if you consider, these are little more bulky also. So chances that, okay, it is true that all are logically possible, but probability of nucleophilic attack from this side will also be less due to a bulk effect. So this is, and second, it will attack in an intramolecular fashion. So intramolecular fashion means ring formation. So we have to check which will produce how many rings. For example, if this attack, this is 1, this is 2, so this is 3, and right now if you come here it is 4, but if you come here it is 5. So we know 5 member rings are more stable, formation is more easier due to proper conformation and orientation, and relatively lesser ring strength, which is more important factor for this 4 member ring, strain ring. So consequently, what will happen? First stage, proton abstraction will happen from this side to generate this carbon. Second step, it will attack this ester molecule, okay, OET. So what will happen? This will go and attack. So it will be and push back. So ultimately, a 1,3 dicarbonyl compound will be produced. This is carbonyl group, and this is the ester. So let's draw the structure. I am drawing the structure here. So since it's a 5-member ring, let's draw a 5-member ring first. This is, now let's consider this is 5. So let's consider at particular, let's consider this is a carbonyl group. Okay, fine. So this is 5. So after that 4 is a methyl. This is methyl. 3 is having CO2 ET attached. 3, 2 and 2 is simple and 1 is attached, and 1 will be attached to CO2 ET. So this will be the product. What is the purpose of giving this problem? Because in question, in exam, you may have such problems and they can provide multiple options. For example, this one option, attacking of this to this, 4-member ring, one option, attacking of this to this, another option, in this way 5-member ring. So multiple options could be generated from such question. So I suggest you please try to understand and keep the logic in mind. How many number of means what is the ring number is more favorable, and that is actually the driving force for a reaction for a particular compound. Okay, and please keep the reagent's name properly in your mind. You don't forget. Then if you don't know the reagent condition, then it will be very difficult for you to predict. Okay, let's discuss this problem. So if you see this problem, this is also a same sodium ethoxide ethanol, and we know one thing, that the ketones I have explained previously prefer to generate the enolate better than this. Okay, now the question is from which side? There are 2 sides possible, 1 and 2. So if this is 1 and this is 2, if we consider, so if carbon ion is generated from 1, then the ring formation, how many? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So it will result a 6-member ring formation. Side by side, if this side attack happens, then how many ring? 1, 2, 3, 4, 5. So 2 chances are there. If reaction happens from this side, it will prepare 6 member. If this side, it will be 5 member. Question: what will produce? So actually we have given 2 options, and you can see this possible. Now, so if this 6 member side happens, then first let's draw 6 member ring. So this is a 6 member ring. After that, in 1 and between 1 and 3, there will be a bridge of 2 carbon. Okay. So let's actually the structure will be this. So this is methyl 1, and this is the bridge. This 2. And second, it will form a carbon. So it is. So there will be another 5 member ring formation from this side. Okay. So this, and now you can see the active methylene means the second step for Claisen condensation to be irreversible is this one. Okay, this one. And abstraction of this proton from this bridge head position. Please keep this thing in mind. This is a bridge head position. So if this proton is abstracted, the carbon ion produced will be resonance stabilized by this, and for that reason this carbon must be sp2, and we know sp2 is not possible at the bridge head position due to enormous strength. So although this step is more favorable, it will not proceed because the last step, which is the main responsible factor for the irreversibility of this reaction, will not be available due to this bridge head position. Consequently, both 5 member thing will be prepared, and actually this 5 member is this one. Okay. And second point, the in between active methylene proton, this could easily be abstracted because it is also a bulky crowded center. This is in between, and if it is abstracted, the generated carbon ion, this will be resonance stabilized very efficiently, and the system will be even more stable. So this is another problem in intramolecular Claisen reaction, or you can say Dieckmann condensation. So you keep this factor in mind. For example, if a question comes using this, then they could have been given these 2 examples, another with another example, and third none of this, or like that. Or they can provide instead of this, they can provide 2 molecules of this can produce another third molecule, and another fourth option could be given an aldol condensation. So in this way, multiple possibility could be offered in front of you during the question paper. So please keep this example in mind. I know it is tricky, but I believe if you learn it properly and do practice, you can solve the question in the exam. Okay, let's come to another example. What? This example. This is also sodium methoxide methanol reflux, means under Claisen condensation. What happens if you consider from here to here? This is 1, 2, 3, 4, 5. So, but Claisen condensation happens from this to this, so actually it will result in 4 member ring, and we all know that 4 member ring are very strained. So consequently this will not happen. So what are the other options? We know that what this reagent do, this reagent abstracts the alpha proton, and alpha proton means here alpha proton of carboxylic group. Here there are 2 alpha proton, 1, and here 1 alpha proton. So abstraction is possible from both sides. So if this is abstracted, then it will react with this to produce a final product. 4 member ring more strained, so less favorable. Second of all, these have only 1 hydrogen, so the equilibrium will not be completely shifted because the last step, you remember, is not possible here. Now the option left is not this, the option left is in case of this. So what happens? If this hydrogen is abstracted, what will be the product? So this will result a carbon ion, means here, and this is the ester. So this is resonance stabilized with this. So consequently what will happen? So this can result in a ring opening. How? It can push this and it can come here, means it may result, and I always suggest that initially don't change the ring number, you do 1 step more hard work, because in this way there is a less chance of mistake. So okay, fine. And this carbon ion is resonance stabilized with this ester group. Fine. So one carbon ion to another carbon ion is generated. But why? Driving force is release of the strain of this 4-member ring. So 4-member ring strain is released here. That is the right now it's the chain compound. So right now this can undergo Claisen condensation. Okay. So what it can do? It can attack this. Okay. Now question, how it can attack? So we need to count the ring number. For example, if we count here, this is 1, 2, 3, 4, 5 and 6. So 1, 6 possible. Okay, fine. And another thing, you may think that it is a trans. Actually, there is no guarantee of geometry. Why I am saying? Because this can be in this side or this can be in this side also. CO2ET. So you can't consider that is a cis or trans. Okay. So don't get in the trap. Second, this bond is under resonance with this, so rotation is also possible under experimental condition. So what will happen? So this will attack. This will attack this ester OMe. So attack here. It will come back and it's a 6-member ring formation. Okay, fine. Let's draw a 6-member ring first. This is 1. Let's draw this is 1. Attached to CO2 ET. Then 2, 3, 4. 4 and 5. 2, 3, 4 and 5. This is a double bond. Okay. And 6. This is a carbonyl group. So this is a 1,3 dicarbonyl. Everything is fine. Okay. And another thing, in number 3 there are 2 methyl. So this is. So okay, fine. This is the product after this workup, because under this alkaline condition also this proton will be abstracted, and after this workup this proton will come back. Initially there will be a carbon ion here, after workup it will appear. So fine, perfectly. After that it's H3O plus, and you can see this is no carboxyl. What happens? It actually hydrolysis. So in presence of H3O plus, this carboxylic group becomes OH. This is hydrogen. So we know that 6-member cyclic transition under heating, you can say acid and heat, this undergo decarboxylation, this. So sorry, I made a mistake. So it's a 6-member, this proton will be abstracted, it will come here and this will come here. Okay. So ultimately it will result in the formation of a 6-member unique product. So keep such example in mind, because final example could be given and it could be asked that what will be the final product with other multiple choices. Even one choices could be carboxylic acid, but when you see the heat and 1,3-dicarboxylic acid, decarboxylation is one of the compulsory factor, and this, please keep this thing in mind. And always keep one thing in mind, that whenever a question is given to you, you have to think every possible aspects in the question, because if you don't understand the question during MCQ, there is a huge chance that mistake will happen. And right now mistake means deduction of number from normal, means your correct question. So don't do those mistakes in the exam hall. And second of all, try to more and more practice. Nobody knows when question will come, and nowadays it is very difficult net question, I believe, compared to my time. So this is another example, another same condition. So what will happen? We can see there is no alpha hydrogen, so directly Claisen not possible here. What can happen? This OMe, methanol, means OMe is an nucleophile here. So it can attack which position? This position not possible, because actually it is an activated double bond, not a withdrawing group attached. So not possible. Only possible here. Ester. So what will happen? It will come here, push back, and it will produce O minus. So it looks, the product will looks like, and as always, don't change the ring strategy. OMe. So this is pH. This is O minus. Okay. And this is, you can see, it's like an enolate. So it will instantly tautomerize to the corresponding ketone. Means this is this pH, and here OM. Now right now you can see one ester is there along with one ketone, and this is a cross Claisen condensation. Under this basic condition, so what can happen? This proton could be abstracted and generate this, and check the number 1, 2, 3, 4, 5. So 5-member ring, which is also a planar, no problem with this benzene, so possible. What will happen? This carbon ion will attack here, it will go, and this bond will eliminate. So consequently, what will be the product? It will result. Think it's a 5-member ring, okay, and let's consider 1. So this is a carbonyl directly attached to benzene, so no mistake. So this is 1, carbonyl is 2, this is 3, this is 4, and carboxyl group 5. And since OMe left, so carbonyl, and here this carbonyl is attached to a phenyl. This is the product. In this way, this is 4. So please keep these examples in mind. These are, I know, very critical examples, and there is a huge chance. It's my personal belief that such type of unpredictable questions, few questions you may have in your NET or GATE exam. So this is formally the end of discussion. So in next video, I shall explain the Claisen condensation and alpha alkylation. Okay. So till now, thanks for watching my video, and if you like my teaching, please give a like, share this video among your friends such that many people will be benefited from my effort, and finally, please press the bell icon to get the notification of every single video I upload, and subscribe my channel Chemistry, the Mystery of Molecules. So stay happy, stay blessed, see you in my next video.